Hello again and welcome to exam questions 10 in Permutations and Combinations series. So in the first question we have 5 first year students and 3 second year students. Now if they arrange themselves at random, what's the probability that all the first year students are standing next to each other? So what we do is we group all the first year students together, so we effectively have 4 items to rearrange. The number of arrangements for 4 items is 4 factorial, but we can also rearrange the group of 5 first year students in 5 factorial ways. Now, as there are 8 people, the total number of arrangements is 8 factorial, so the probability is going to be 4 factorial times 5 factorial over 8 factorial, or 1 over 14. Next, we have to work out the probability that all the first year students are standing next to each other and all the second year students are standing next to each other. So here we group all the second year students together as well. So effectively we have 2 groups to rearrange, and we can arrange the groups in 2 factorial ways, but we can also arrange the students within the first group in 5 factorial ways and the students within the second group in 3 factorial ways. So the probability is 2 factorial, 5 factorial, 3 factorial over 8 factorial, which is equal to 1 over 28. And then we're asked to find the probability that no second year students are standing next to each other. So let's call our second year students S1, S2 and S3. Now if all the second year students were standing together, we'd have 6 items to rearrange, and you'd be able to arrange them within the group in 3 factorial ways, which would give us 6 factorial times 3 factorial arrangements. But what if 2 of them are together and 1 is separated? For this, it's easiest to write down a little table, and we'll call the group with 2 students together Group A, and the group with 1 student on their own Group B. Then if we write down all the different arrangements, you'll see there are 6 different ways to rearrange these 2 groups. Then we'll have to write down another table with Group A and Group B interspersed within the first year students. However, on each line of this table, there are 5 first year students that can be organised in 5 factorial ways. So the total number of arrangements where 2 students are together and 1 is separated is 15, because there are 15 arrangements, times by 2, because we can switch A and B, times by 5 factorial, because the first year students can be organised in 5 factorial ways on each line, times by 6, because there are 6 ways to organise the A and B groups, which gives us 21,600. So the number of different ways the second year students can sit together is when they're a group of 2 and 1, which is 21,600, plus the number of ways they can sit together as a group of 3, which is 4,320. So to work out the total number of ways they do not sit together, we subtract that number from 40,320, 8 factorial, which gives us 14,400. So the probability is 14,400 divided by 8 factorial, and that equals 5 over 14. In the next question, we have these 10 letters written on separate pieces of card. To find the probability that the arrangement starts and ends in the same letter, first we'll work out the total arrangements, which is 10 factorial, because there's 10 items to rearrange, and then we're going to work out how many arrangements there are if it begins and ends in the letter A. Well, there are 5 letter A's to choose from, so we can arrange those in 5p 2 ways, and then there are 8 letters left to rearrange in 8 factorial ways. And if we put the numbers into the permutation formula, we end up with 20 times 8 factorial. Next, we're going to do the same, but with the arrangement starting and ending with the letter B. Now, there are 3 B's to choose from, so we can arrange those B's in 3p 2 ways. And again, because we still have 8 letters left to rearrange in the middle 8 spaces, we times that by 8 factorial. And using the permutations formula, this gives us 6 times 8 factorial. And finally, the arrangement could start and end with the letter C, but we only have 2 C's, so it's 2p2 times 8 factorial. I've shown the formula, but you don't really need it. You know there's only 2 ways to organise 2 C's, so it's 2 times 8 factorial. If we add these up, we get the total number of arrangements, which is 28 times by 8 factorial. So the probability is 28 times 8 factorial divided by 10 factorial. And if we write it like this, we can cancel the 8 factorials out easily, and we have 28 over 90, which is 14 over 45. As always, thanks for watching, and if you could hit the like and the subscribe, I'd really appreciate it. Thank you very much.